Alright folks, welcome back. We are going to be working section 10.6 on the inverse trig functions, and this is part 2 of the video series. There's just a couple problems we're going to do here. Shouldn't take too long. But first I want to get started and talk to some of you TI-84 owners. I want to show you how to graph arcsecant, arccosecant, arccotangent on the 84. So let's look at this statement right here. It says y equals arcsecant of x. This means that y is the angle whose secant is x. But it also means this. Y equals arccosine of 1 over x, the angle whose cosine is 1 over x. So if you want to graph arcsecant of x, you can graph arccosine 1 over x, and those graphs will be the same. Now let's scroll down and look at another example. Arccosecant works the same as arcsecant, but arccotangent is slightly different. If we want to graph y equals arccotangent of x, we're going to graph pi over 2 minus the arctan of x, and that's because of the phase shift between those two graphs. So just wanted to reach out to you TI-84 users there and give you a little bit of extra added power to your calculator. Now let's get into the problems. So here we go. We're going to look at evaluating some exact values of arcsecant, arccosecant, and arccotangent. The key thing I want to remind you here is don't forget to consider the range of each of these functions. What is the allowable output values? What are the allowable output values for these functions? And I'm just going to flip back here to the notes page from the previous section 10.6 part 1. This table right here is of critical importance to you when doing inverse trig. So this first example we're looking at is arcsecant of negative root 2. Remember, the only outputs we can come up with for arcsecant are in this range right here, from 0 to pi over 2, skip pi over 2, and then all the way up to pi. Okay, so let's get started on this. So we have arcsecant of negative root 2. Perhaps I could write it a little better for you. And you know, my personal preference is I always think about the trig stuff in terms of sine and cosine. So I'm going to rewrite this as arccosine of negative 1 over root 2. Which, if you remember how to rationalize anything with a square root in the denominator, if I have negative 1 over root 2, I can multiply both numerator and denominator by root 2. And I'm going to get negative root 2 over the square root of 4, that's root 2 times root 2, which is just plain old 2. So this is the same as the arccosine of negative root 2 over 2. Now we're ready to answer the question. Don't forget about the range. Okay, the range of arcsecant is from 0 to pi over 2, and then we got to skip that. Why do we have to skip pi over 2? Because the cosine of pi over 2 is 0. 1 divided by 0 is undefined. So we have no output. It's not possible to get pi over 2 as an output from the arcsecant function. And then we go up to pi. Okay, so what angle in this range has a cosine of negative root 2 over 2? Well, let's see, that's going to be in quadrant 2 because that's where the cosine is negative, and I believe that's going to be 3 pi over 4. Okay, now folks, I'm really not trying to hide anything from you here. These, if you wanted them to be, these could all be calculator problems. You know, I could go to a calculator page in my TI Inspire and say, hey, Mr. Vast just asked me about the arcsecant of negative root 2. I wonder if my calculator will just, you know, is it possible for me to just grip it and rip it on my calculator? Sure is. There's your answer, 3 pi over 4. But folks, I caution you from doing this, because if we have a non-calculator test, you're going to be straight out of luck. You really have to understand how the trig works to have a deep understanding, understand the fundamentals of what's going on here. Okay, so let's take a look at the next example I have. Next example is find the exact value of arc cosecant negative 2 root 3 over 3. Let's go ahead and get started. So the arc cosecant of negative 2 root 3 over 3 is the same as, remember I like to think about these in terms of our primary trig function, sine and cosine. This is going to be the arc sine of negative 3 over 2 root 3. Uh-oh, I need to rationalize that denominator because I don't have any idea what angle has a sine ratio of negative 3 over 2 root 3. So let's take a look at rationalizing that. If I have negative 3 over 2 root 3, multiply both sides by root 3 over root 3. So if I do that, I'm going to get negative 3 root 3 over 2 times, well, let's see, root 3 times root 3, that's root 9. That's the same as 3. Okay, now I can, now it's pretty easy for me to see that those 3's cancel. And I have negative root 3 over 2. So this is the same as arc sine of negative root 3 over 2. So now I have to consider the allowable range for, you know, if I go back to arc cosecant, what is the range of arc cosecant? Well, the range of arc cosecant is from negative pi over 2 to 0, and then I have a hole at 0 up to pi over 2. And I really think you should be able to think through this logically, why this works. We have restricted the domain of these arc functions so that they are functions, so that we can get a single output for a given input. And the sine function, the sine ratio, goes from a minimum of negative 1 to a maximum of positive 1. So if I were to look at the unit circle, a sine ratio of negative 1, that's down here. And then a sine ratio of positive 1 is all the way up here. The problem with this point right here is the sine ratio is 0. So to have a continuous domain without any, well, just to have, to be able to go from negative sine values to positive sine values, we decide to go from negative pi over 2 up to pi over 2. Yes, we have a gap right here because the sine of 0 is 0, and we can't divide by 0. We're looking at arc cosecant here. So this, hopefully this picture helps you understand why the range has that hole at 0 and why we go from negative pi over 2 to pi over 2. Okay, so arc sine of negative root 3 over 2, what angle in this blue region has a cosine ratio of negative root 3 over 2? Well, that would be negative pi over 3. And again, if you want to check your answer on your calculator, you can. Just make sure you understand how that problem works. Let's look at the last problem on this page before we continue on and look at some other stuff. Find the exact value of arcsecant negative root 2 on this range. Okay, so that's I've changed the range for you, and if you want, go ahead, take a look at your textbook and read. Your author talks about why he does this. He's now looking at angles in quadrant 1 and angles in quadrant 3. Now remember, arcsecant is related to the cosine because secant is 1 over cosine. Cosine is positive in quadrant 1 and it's negative in quadrant 3. He's basically skipped over quadrant 2. And your author describes why he does that. There are some problems in WebAssign that look at this modified range for arcsecant. I just want you to be familiar with it. That's why I'm talking about it now. So arcsecant of negative root 2 is the same as arc cosine of negative 1 over root 2, which is the same as arc cosine of negative root 2 over 2. And in quadrant 3, I have to come up, so first of all, I'm looking for an angle whose cosine is negative, And in this range, that would be quadrant 3. And the angle that has that cosine ratio of negative root 2 over 2 in quadrant 3 is 5 pi over 4. There you have it, folks. That's all for this front side of the notes. I'm going to go ahead and shut it down here and do a separate video for the problems on the back side.